Good morning, everyone. Today I, CR Deepak Kumar, roll number 1833009, will present my tasks. So, the first question is social network ads. So, this is the notebook file, Python notebook. So, this is the code for my decision boundary task. So, this is the first task for me. So, social network ads. First, I have imported all the libraries as you can see, NumPy, Pandas, Matplotlib, and listed color map Seaborn. And after that I have uploaded the dataset, so it's an Excel file. So this is a header, so it shows the first 5 rows of the dataset, and this here is the all the columns present in the dataset. And I have pre-processed the data because over here gender is in a categorical format, so I have to convert it into a numerical format. So I've used the label encoder to convert it into a numerical format. And after this I have defined the random forest algorithm as CLF. And after defining the random forest algorithm, I have used random forest classifier to identify important features in the dataset uh, compared to the white variable. So, which of the independent variables is the most important for predicting the target variable? So, I found out that feature 1 and 2, which is age and estimated salary, is the most important, and I moved ahead and put that as my independent variables, and my target variable is purchase. So these are my x and y for my code. And then I went on ahead to analyze the data set. So this is the count data set. So this plot shows how many people did not purchase and how many people purchased from the ads. So over here you can see that the people who did not purchase are almost more than 100 compared to the people who purchase. So people who did not purchase is 250, and the people who purchased is close to 150. And now moving on. So this plot shows the range of the age factor who purchased. So how what was the range, like the minimum and the maximum age who purchased and who did not purchase. So the minimum value age for the people who did not purchase is 18, and the maximum plus the outlier could be around 58. And as for the people who purchased, I think the minimum value is around 28 and the maximum is 60. So the box plot shows us the range of the age at which the people who purchased and who did not purchase. And these two plots will be significant in confirming the decision regions which I will create from the random forest and the AdaBoost and XGBoost regressor models, which I'll show you after the analysis. So again, this is another bar plot with this time the analyzing the estimated salary of people who purchased and who did not. So as you can see, the people who purchased, the range for the people who purchased is quite high, and obviously for the people who purchase the they have the maximum salary, and the minimum is around 20,000, while the people who did not purchase, the minimum is around maybe 18,000, and there are some outliers which are more than 14,000. So this these two plots shows us the range of the age and the estimated salary amongst the people who did not purchase and the people who purchased. So now moving on to the models which I have created. So first I have defined the Adabus classifier with the base as the random forest classifier. So as you can see, I've kept Adabus classifier and estimator as 52 and base estimator as CLF, which as I showed earlier is the random forest classifier. So first, before applying random forest classifier with the Adaboost, I have used the XGB classifier. So XGB classifier I have shown here. So I have first imported the library for XGB classifier and also imported the decision viz through the library of Yellow Brick, and from sklearn I have taken a train test split to split it into a training set and the testing data sets. Why I have done the splitting is because I wanted to check whether my model overfits or not. Therefore, I have split the data into training and test set. So first I have done XGB classifier and trained it on the training set. So X train and Y train, and then from the fitted model it draws the region according to X and Y, and which dot shows us the plot, and now here is the prediction score for the training data set. And obviously the independent variables have been scaled to have a similar measure for better predictions. So now moving on to the plot for the training set with XGB classifier. So as you can see, the x-axis is the estimated salary, and this is the y-axis has the age. So as the prediction score is around 98.7%. So as you can see here, the plot also shows it is quite accurate, and wherever there are blue regions, the blue dots are present, and wherever there are green regions, the green dots are present. So as you can see from the plots which I had shown earlier, the decision regions made in this plot also are quite scattered for the one people who purchase, so which is the green region. So the green region is the other people who purchased, and therefore their range is extremely scattered and at an extremely wide range, while the people who did not purchase is quite constricted. So as you can see, that is the blue region, and it's the region is quite small because the range for the people who did not purchase according to the age is quite constricted and small. So therefore the region is smaller compared to the people who purchased. So green are the people who purchased, and the are the people who did not purchase. So this is the plot created from the training data set. So now moving on to the test data set, similar procedure has been followed. Only over here I have done X test and Y test, and over here is a similar accuracy. So we can conclude that XGB classifier does not overfit for this model, and we can go ahead and say that it is extremely accurate for predicting the decision regions for this model, for this data set. So again, you can see in the test data set, the people who purchase their range is quite high, and therefore it is quite scattered, and therefore the green region in this plot is much more bigger compared to the blue region, which is the region where the people did not purchase. So that is, since it is quite constricted, since the range is quite constricted, the region is smaller compared to the green region. And you can also see that the plot is quite accurate. There might be some two or three dots misplaced in the region, but otherwise it is extremely accurate. So now moving on to the Adaboost classifier. So over here again I have split it into a training set and the testing set, but only over here I have used ABC, which is the Adaboost classifier with the random forest as its base. So this is the plot made from the training set, and as you can see the accuracy is 100%. So it is extremely it is a perfect plot. And again, as the XGP classifier showed, Adaboost also shows the same, that The people who purchased, their range is quite high compared to the people who did not purchase. Therefore, we can conclude that the range of the people who did not purchase is quite constricted compared to the people who purchased. So this is for estimated salary and the age, which I have said before. And you can also see that the plot is extremely accurate and there have been no dots which are misplaced according to the colored regions. So now moving on to the testing set. So now again this is the testing data set, and you can see here it's 99% accurate. So the accuracy is quite similar, and therefore we can conclude that the model is not fitting, and we can also conclude saying that AdaBoost classifier with the base estimator as random forest classifier is the best classifier for this data set, and we can say that it is the best, and the AdaBoost classifier is the best model to be used for this data set. And again over here you can see that the people who purchased, their range is quite high and the green region is larger than the blue region. And since the blue region consists of the people who did not purchase, and their range is quite constricted, so the blue region is smaller compared to the green region. And you can also see that the plot is quite accurate. So uh, for conclusion, I have used the XGB classifier and AdaBoost classifier with base estimator as random forest classifier, and I received an accuracy of 99% with the AdaBoost classifier. Therefore, I can conclude that the AdaBoost classifier with the base estimator as random forest classifier is the best model to be used for this data set. Thank you.